Hey, welcome back. In this video, we're going to tackle a question that's asking us to find the foci and the slant asymptotes for a hyperbola. Specifically, we're being asked to find the foci and the slant asymptotes for the hyperbola, described by the equation here, 4x squared minus y squared plus 32x plus 6y plus 39 equals 0. And you might be thinking off the bat like, hey, no problem, I can do those things for you if you gave me an equation that was a hyperbola, and this definitely doesn't look like it. And actually this is an expanded version of a hyperbola equation. And what we're going to need to do is employ the trick of completing the square in order to get this in our known general form. So the first thing I'm going to do with this is I'm going to organize these terms into x and y terms and move the constant over to the left hand or right hand side of the equation over there. So let's put all the x terms over here. So first thing I'm going to do is write this 4x squared plus 32x, and then I get what my y is, negative y squared plus 6y, subtract over the 39. All right, so I'm just setting up the work of completing the square. We've seen this with circles and other objects earlier, but this will hopefully be a good reminder for you, and it might look a little bit different when we do the work. The next move I'm going to do is really crucial. What I'm going to do is factor from these groupings of x and y terms. I'm going to factor out the coefficient in front of the squared term. I don't have to do this to complete the square, but this is always the easiest way to do this. So what I mean by that is in this case, I'm going to factor out a 4. So I'm going to write this as 4 times x squared plus 8x. And then I'm going to leave a blank right here. This is where I'm going to be completing the square for this trinomial or this quadratic inside the parentheses here. And in this case, I'm going to factor out the negative here, and this will only have the effect really of changing the sign of this term. And so this becomes y squared minus 6y, and then this minus 39 is unchanged. Okay, so here comes the important business. What I'm going to do is inside the parentheses here, I'm going to complete the square. That's the action of dividing this coefficient by 2 and then squaring it. So 8 divided by 2 is 4. 4 squared is 16. So I'm going to add 16 here. And then I'll go over here and do this, and I'll talk about needing to balance the equation. But here I got negative 6 divided by 2 is negative 3. Negative 3 squared is a positive 9. And so there is the work I've done of completing the square. Now, really importantly, and this is the tricky thing, if you've done stuff like this before, you would say, well, hold on, you can't just go randomly add 16 and 9 to equation. You got to add 16 and 9 to both sides of the equation. The trick is I've added these values inside these parentheses. So in this case, for instance, I haven't just added 16 to the left-hand side. Because this 4 will be distributed to each of these terms, I actually, when I added this 16, I actually added 64, or 4 times 16 to this side. And again, to verify that, I could just distribute this 4 to all of these terms. You would say, yeah, for sure. You added a 64 on from what this was originally. And in the same way, I haven't actually added 9 here. So when I distribute this negative, this will become a minus 9. So I've actually given this coefficient out front here of negative 1 and this plus 9. I've actually subtracted 9 from this side. What that means then as a reaction is it's not a huge deal. I just need to take into account those coefficients and do the work on this side. So I'm not going to add 16 and 9. What I'm going to do is add a 64 and subtract 9 from that side of the equation. After that, I've done the major work. The beautiful thing about this is now that I've completed the square, I know how this perfectly factors. This will factor it into x plus 4 squared, and this will factor into x minus 3 squared, or in other words, x plus 4 times x plus 4. That's all of the work of completing the square. And so I'll write that here, right? By the way, the 4 comes from that number that was divided by 2, right? It's always half of this coefficient, just to, if you're trying to remind yourself of this process. This becomes 4 times x plus 4 squared minus, and then this becomes y minus 3 squared. And when we calculate all of this jazz out, we get that this is 16. So at this point, you might be thinking, well, good, except for we aren't actually in the standard form. And the good news is it's not too difficult. Once you've done this work of completing the square, we know we want this equal to 1. That's how we analyze this standard form. And again, this is the equation of a hyperbola, but it doesn't help us with our techniques that we've created for sketching these graphs and finding the foci and the slant asymptotes and all that. So let's get this equal to 1 by just dividing everything by 16, both sides of this equation by 16. And when I do that, I get this term gives me x plus 4 squared over these reduced to give me a 4. And this is minus, that just stays the same. There's no canceling there. Over 16. And this equals 1. So here I have done the work of rewriting this equation for a hyperbola in its general or standard form. I now look at this and I can analyze the A values and the B values. I see the transverse axis is horizontal. It's oriented parallel to the X axis because this term is positive. I have this shifting left 4, up 3 units. But that's the work of writing it in its general form. Let's now do the work of finding the foci and the slant asymptotes. And actually for me, I feel like sketching a real quick graph, which helps me with those. So I'm going to clean some stuff up and let's set that up. All right, again, the question is asking specifically for the foci and the slant asymptotes. What I'm going to do is I'm actually going to look at a quick sketched graph of this just to provide substance for how I'm going to attack those two statements right there. First of all, I want to identify the 3 main things that I can see right now that I have this, that always when you analyze a hyperbola or a conic section, I think are useful. First, number 1, since this x squared, the x term is the positive term, I know my transverse axis is horizontal. If there wasn't a shift here vertically at all, this actually would be on the x-axis. But I see that this has been shifted. But what I do know is that the transverse axis is horizontal. Or in layman's terms, how I like to think about it, that means that this hyperbola is oriented along the x-axis or oriented horizontally, open like this. So that's what that says. I also know I have A and B values, which are the square roots of these. So A squared is 4, which means A equals 2. That is from the center point, described by the shifts here. I'm going to go 2 units along horizontally in the direction of X. And that B is 4, so I'm going to go up 4 and down 4. And then finally, I can see here from the shifts that have happened to the X and the Y is that the center is at -4 and +3. And so the first thing I'm going to do is to sketch this right here. So given my graph here, -4, 3, so 1, 2, 3, 4, 3, right about there. That is going to be the center. Then what I can do with this information, with this 2 and the 4, is this gives me this box. So again, I should label this right here. I am at -4 here and up at 3. And then I'm going to go up, so I'm going to go to the right 2 units. So 1, 2, and this is going to be this boundary of the box, the slant asymptote box. And then I'm going to go 2 this way. This will be the left boundary. And then up 4 and down 4. So I'm up 3. Ooh, I actually need to go down here, down to -1. So I'm up 3. So down 4 is 1, 2, 3, 4. Right along here. So I can actually sketch this part of this hyperbola box I'm creating. And then from 3, I got to go up 4. So 1, 2, 3, 4, up here to 7. So here is my slant asymptote box. And then I am just going to right away here, I'll throw in these asymptotes. They go through the middle and these corners. Let's see how well I can do this. Heck yeah. Not bad at all. I shouldn't get too cocky. I gotta do this other one. Pretty straight. Oh. All right, good enough. Okay, so there we have that. And then let's do it in pink here. I'm gonna sketch my graph. So importantly, I'll throw this in, is that I have, as stated right here, the transverse axis runs like this. This isn't super important, but what it does help remind me is that I am oriented horizontally here, but also where the transverse axis intersects this box is where my vertices are. And so I have a vertice there, and then here is my sketch of this hyperbola. All right, that work was really just for fun. Let's get back to the work we've been asked, which is the foci and the slant asymptotes. First of all, the foci are pretty straightforward. The foci are just based on this c value, and I know for hyperbola that c squared equals a squared plus b squared, and so c squared in this case is 4 plus 16, and I'm just going to write that as 20 right there, right? Because a squared is 4, b squared is 16, which means that c equals the square root of 20. Okay, and this is a little bit more awkward than when we have unshifted hyperbola, but importantly, this c value is the distance from the center along the transverse axis. So importantly here, I have a center at -4, 3, and what I want to do is horizontally move c units this way and c units that way. I could do the idea of, I could approximate this. I know this value is between 4 and 5, right? Because the square root of 16 is 4, the square root of 25 is 5. So let's say it's like 4.5 or something like that. But it's not really important. All I know is what I'm going to do is take this center point, I'm going to move c units this way. So I'm going to have a foci somewhere right here. And that location is -4 plus the square root of 20, comma 3. And again, all I'm doing is taking this x value of -4 and I'm adding the square root of 20 to it to move that way. I could give it a decimal approximation. This x value is something like negative 4.7 or something like that, or actually it'd be a positive 4.7. Oh crap, it should be over there. Who cares? It didn't ask me to graph it, it asked me just to write it. So there it is, right there as the foci. And then on this side, I'm gonna move c units this way, which means I'm gonna take my x value and subtract square root of 20, and so my foci is somewhere out here, and it's -4 minus the square root of 20, comma 3. And again, all the information I needed to be able to do that was, one, I needed to know my center. I also needed to know which way this was oriented, because what I was thinking is, am I moving c units horizontally or vertically? Well, because it's oriented horizontally here, my transverse axis is parallel to the x-axis because my x term is positive. I know I'm going that way, and I'm adding and subtracting that c value to the x value of the center. All right, finally, let's talk about the slant asymptotes. I've drawn a great graphical representation of those slant asymptotes, but we're being asked to give the equation of the slant asymptotes or identify them. And actually, it's not too difficult, especially if we employ our friend, the point-slope form of a linear equation. The point-slope form just needs a slope and a point. Beautifully, first and foremost, our asymptotes go through our center. So we're going to use this as a point. Then all we really need is to find the slope. But the asymptotes come from this box that we created. The slope I can identify by how much I went up and over to get to this corner right here. So I know that my b value, which was my rise, this is 4. And the 2, which comes from the square root of 4 here, was how much I went over. So I know that this line right here has a rise of 4 and a run of 2. And actually this line is just the opposite, or not the opposite. Well, it is the opposite. It goes up 4 and back 2. So whatever I get from this is just going to be negative. So importantly here, I have 2 slant asymptotes. The first one has a slope of 4 over 2, which is just reduces down to 2, and it goes through the point, which is the center at -4, 3. And so this will be my first asymptote. My second asymptote is very similar, except for it's going to have the opposite slope. So instead of 2, it's a -2, and it goes through that same point that they share at -4, 3. And so that's actually all I need to do these. Again, I'm going to use the point slope form of a linear equation, and it just looks something like this. It's y minus the y value here of 3 equals the slope, which is 2, times x minus my x value of the point, which is -4. Obviously, this will become an x plus 4. And then over here, I have y minus 3, same thing there. Actually, the only difference between these two will be that I have a negative slope for this one instead of a positive slope, and it's x minus -4. So just to clean things up and put a bow on it, I just took care of this subtraction of a negative. So this is an x plus 4 in both cases. And so just to get both of these here for the asymptotes, distribute this to get 2x plus 8. Add this over. This first one becomes y equals 2x plus 11. And this one right here, I'm going to distribute the -2 to get -2x minus 8, and then add the 3 over. And so this is y equals -2x, and it looks like -5. All right, just to review what this video covered. First, we're given this crazy equation that we had to turn into a general form of a hyperbola. Didn't take too much work. Once you do the work of completing the square, feel comfortable with that, and make that little trick with those coefficients out front, don't forget to multiply those by whatever you're adding inside the parentheses. After that, I chose to sketch this. Quite honestly, anytime I do a problem like this, I'm always going to sketch them. The reason is when I start getting answers, I don't want to memorize a bunch of formulas. And things like the idea of the foci, with like, what am I going to do with the foci? I don't need to memorize a formula for the foci of a shifted hyperbola. What I do is just actually sketch the graph using the A and the B in the center. I can quickly graph those, and then knowing that it's oriented this way, I then can logically deduce that it's going to be, in this case, the square root of 20 units this way and that way. And then finally, when it comes time to find the asymptotes, I don't need to, again, memorize this formula for how do you find the asymptotes of a shifted hyperbola. No. I have a center, and I created this box that created those asymptotes. I sure as heck can find the equation because I know the slope. It came from these A and B values that I created this slant asymptote box from. And then I know a point. It's the dang center that they all go through, which then I can use, again, point slope formula to find the equations in slope intercept form of those two slant asymptotes.